In this lesson, we'll go over solving linear inequalities. Okay, so our objectives are to understand inequalities, and then we'll solve our linear equality example problems. So inequality. An inequality compares values. So for instance, in solving linear equations, we talk about things being equal to each other. With inequalities, we're going to compare. So for instance, 2 is greater than 1. Or we can have less than, greater than, or equal to, or less than or equal to. Something to keep in mind with solving inequalities is that it is very similar to solving linear equations, but there's a couple things to note. Multiplication or division by a negative means that we must change or flip the inequality sign. And then the solution is usually a set of numbers rather than just a number. So for instance, when solving equations, we would get something like x equals 3. This is for an equation. For an inequality, we might get something like x is greater than 3. Okay, so here it's very important that we include the entire set of numbers in our solution for whatever we get. Example 1. Solve the linear inequality. Simplify your answer as much as possible. And I'll show you a way that you can kind of check your answers with these. So as we talked, solving linear inequalities is very similar to solving linear equations. We want to determine the solution set, meaning we want x by itself. So in this case, we'll start off with adding 23 to both sides. So we bring down the 6x. Negative 23 and positive 23 cancel out. We don't need to change our inequality sign, so it comes down as a less than. And 1 plus 23 is 24. And so to get x by itself, 6 times x, we divide both sides by 6. 6 divided by 6 is 1, so this is just 1x or x. We don't need to change the inequality sign since we didn't multiply or divide by a negative. And 24 divided by 6 is 4. So in this case, our answer is x less than 4. That whole thing is important because when we talk about x less than 4, it can be 3, 2, 1, negative 100, anything that is less than 4. You're not required to graph these, but if you wanted a visual representation of the solution set, I'm just going to draw a quick number line. We're talking about values that are less than 4. So to check your answer, you can pick any value that this line corresponds to. So we can check 0, for instance, to see if the inequality is true. So here we're going to check. So what we do when we check is we always go back to the original. So 6 instead of x times 0 minus 23, and we want to know, is that less than 1? And so we simplify both sides. 6 times 0 is 0, less than 1. And so we come up with negative 23. Is negative 23 less than 1? It sure is. So that means that the solution we found, the set of numbers, x less than 4, is probably true. Example 2. Solve the linear inequality. Simplify your answer as much as possible. So in this case, we start off similar where we're trying to determine the solution set. So we want to know what x is less than, greater than, less than or equal to, greater than or equal to, so that we know the solution set. So we start off by subtracting 1 from both sides. We bring down the negative 7x. This is greater than or equal to, and 29 minus 1 is 28. And we didn't change the inequality because we didn't multiply or divide by a negative. Next, we have negative 7 times x on the left-hand side. We divide by negative 7 to both sides. And so negative 7 divided by negative 7 is just 1x. In this case, we divided by a negative. So that means that we must change or flip the inequality symbol. And 28 divided by negative 7 is negative 4. Okay, so in this case, our answer would be x less than or equal to negative 4. And you can check your answer in a similar way that we did for example number 1. Okay. One thing to note on here is that we're only changing the inequality sign when we multiply or divide by a negative. So I'm actually going to erase this check mark here and create a new problem. Let's say we have negative 7x plus 1 greater than or equal to negative 29. Okay, so instead of a positive 29, we'll do a negative 29. So I can highlight a couple of things for you. So first we start off the same way. We subtract 1 from both sides. So we have negative 7x greater than or equal to negative 30. Okay, so we still don't change the inequality symbol at this step, even though we got a negative on the right-hand side, we didn't multiply or divide by a negative. Next, we would divide both sides by negative 7. And so we'd have x. And now since we divided by a negative, we change the inequality sign. And negative 30 divided by negative 7 is positive 30 over 7. It's okay to get a fraction. But a couple of things I want to point out here as well is that even though our answer, 30 over 7, is positive, we're still changing the inequality symbol because we divided by a negative. So thank you for watching. If you need additional help, feel free to contact me for any questions, and there are some free resources available for you as well.